In this recording, we're going to introduce the imaginary unit, I. So let's start out by solving some quadratic equations. And we'll solve these by square roots. They're all simple enough to solve by square roots because there's no b value in these quadratic equations. And let's simplify all our answers. So we'll start out with this one. We said when you have a x squared, you can solve it by square roots. When you square root both sides, you get the absolute value of x, right? And of course, the square root of 36 is rational, so we just write a 6. And that leaves us with x is equal to the positive or negative 6. Get two roots, right? 24, not so easy because 24 is not a perfect square, but we'll handle it. Squaring both sides. Again, we get the absolute value of x when we square root a square. And on the right side, well, 24 is not a perfect square. It does, however, have a perfect square 4 that is a factor of it. So you can write as square root of 4, square root of 6. Which is going to lead us to 2 square root of 6. At this point, we can write it as x is equal to positive or negative 2 root 6. Okay, third example. This one we have to isolate the square first, so let's do that by subtracting 21. That's going to give us a negative 16 on the right-hand side. Let's proceed to square root both sides. And just like before, well, shoot, there are no real solutions here. There are no real numbers that you can square and come up with a negative, right? Positive times positive is positive. Negative times negative is positive. There's no way you're going to get a negative here. So we would say no real solutions. And that's what you've said in Algebra 1 because that's all you knew. We're about to expand your horizons a little bit. Let's look at some of the history behind the math that you knew. Okay, because you didn't always know about square roots, right? You had to learn incrementally. So don't write this down. This is just unless you want to. This is a brief first review of the history of numbers, sort of, like in the order you knew them. Okay, so first off, you knew about counting numbers. That was the first thing you knew, like just 1, 2, 3, 4, 5, right? Of course, you didn't try to solve equations with it, but that was the first type of equation that you solved. You can see that when you subtract 2 and divide by 3, you're going to get a nice counting number. Okay. Next, you didn't know about 0, but later you did learn about the number 0, and so when you subtract 23 and divide by 3, you would get x equals 0. 0 is the only number that can solve this equation, so that includes the whole numbers. Later, you're introduced to negative numbers. Okay, you didn't initially know about negatives, but maybe thinking about temperature and stuff like that, losing money, there were ways you talked about negatives. And you can see that this would have a negative solution for x. Once you got into maybe, I don't know, middle school at some point, you learned about rational numbers. Okay, or actually even earlier, elementary school, you learned about rationals. You can see when we subtract 28 and divide by 3, we're not going to have a nice integer answer. It's going to be a fractional or a decimal answer. This was, I was thinking of middle school, is when you learned about square roots, right? Irrational numbers. So if I add 5 to both sides and square root both sides, I'm going to get an irrational number because 5 is not a perfect square. It's a decimal that doesn't repeat or terminate. So my point here is all along you've learned about different classes of numbers and you've just dealt with it, right? It seemed confusing at first, but now it doesn't seem so hard. So I'm going to introduce you to something here. What if we subtract 1 from both sides? So that's going to leave us with x squared equals negative 1. So that's not so easy to do because there's no, as we said before, no real number that you can square and get a negative. But that's where we need imaginary numbers. This leads us into this notion of the imaginary unit. Just like before, all right, we had to deal with something that wasn't an integer. Oh, a fraction. Fractions are scary. We can't handle that. But eventually you could, right? Radicals are scary. We can't handle that. Eventually you could. Now you've got this new number called the imaginary unit. When we square root both sides, the square root of negative 1, we're going to give a name to it. It's not a real number, but we can do math to it. We can do operations to it, and it has applications. It's called I. Okay? So let's do some work with I. First, let's define this thing. The number I, the definition, the square root of -1 is called I. It's called the imaginary unit. So let's check out the powers of I, because there are cyclical patterns that we're going to identify here. So first off, I is just I. Fine, it's the square root of -1. I squared, when you take -1, which is I, and you square it. Okay, so I'm taking an I and then squaring it. Well, the square of a square root just gives us the radicand, right? So that would be a -1. I to the cubed. Well, I cubed. Let's start out by splitting this I cubed up. Let's split it using our exponent rules into I squared times an I. Well, of course, I squared we just defined as a -1. And that's kind of a critical one. Let's put a star by that. It's really important that you know I squared is -1. Well, that would be a -1 times I, because I squared became -1. Well, of course, that makes -I. I to the 4th. Well, we can split it the same way we split up I cubed. You'd have an I squared times an I squared using your exponent rules. This is the product property of exponents. And so I squared is -1. So you have a -1 times a -1. Well, of course, that's a positive one, right? All right, so we've got 4 of them down. Let's jump to I to the 5th. Well, I to the 5th, I'm going to express as I to the 4th, because out of all those 4 numbers, I like 1 the best. That's the easiest number for me to work with. I could split I to the 5th any way I like, but I'm always going to use a power of 4, because 1 is an easy number to multiply by. So it's I to the 4th times the remaining I factor. Okay? So that's just 1 times I, which gives me I. Now, if this is a little confusing for you, I'm expecting that, right? It's difficult at first, but you're going to get it. All right, so I to the 6th, let's split it as I to the 4th times I squared, because 4 plus 2 equals 6. Well, let's look up on our table here. I to the 4th is 1 times -1. That's going to come out -1. You're starting to see a pattern here, how these are forming. I to the 7th, we'll call it I to the 4th times I cubed. Well, I to the 4th, that's a 1. I cubed, that's a -I. So that's just going to come out to be 1 times -I, which of course is -I. Finally, I to the 8th is just I to the 4th times itself. Well, that's going to consist of 1 times 1, which is 1. Now we could continue doing this to whatever number we want, but let's not. I think you see the pattern. It keeps repeating here every 4. So let's generalize. In general, if we have an exponent here, like a 17, we're going to separate the exponent, 17, into the highest multiple of 4 that precedes it, and a remaining exponent. So we'll write that out. Okay, so I'm going to write this as I to the 16th times I to the 1st. Because really, when you think about it, I to the 16th is I to the 4th to the 4th, which would be really 1 to the 4th, right? Times an I, which equals obviously 1 times I. It's all equal to I. Now you can start skipping some steps here, but I'd like you to write out this much. Make sure you at least have this step, and then you jump to the I. So for I to the 28th, I got to think about that. Would I reach that counting by 4s? Well, yes, I would. So that's going to come out to be I to the 4th. That is a multiple of 4 to the 7th. So I to the 4th is just 1. It's 1 to the 7th. It's 1. So let's see if you can work out I to the 42nd, I to the 59th, and I to the 101st on your own. Then play the recording to check your answers. Okay, so I'll just do the work here and you can check and see how you did. Thanks for watching.